Welcome to this module on the fundamentals of the mechanical concepts of work, power, and efficiency. Today we're going to learn about the definitions of work done, power, and efficiency, and to understand the relationships between these three concepts. We will also perform simple calculations using work done, power, and efficiency. Work is done when energy is expended to move an object. Typically, this involves applying a force over a specified distance. Hence, the formula for work is force times distance. And the units for this formula are force is in newtons, distance is in meters, and work is in joules. Now, we've seen a similar formula before in torque equals force times distance, but the two should not be confused. In the case of work, the force and distance are in the same direction, whereas for torque, it is force multiplied by the perpendicular distance. So the two are not the same, even though they do look similar. So let's work through an example to apply the formula for work. Here we have Anthony pushing a wooden crate across the floor with a force of 100 newtons, and he pushes it for 20 meters. And we need to calculate the work done by Anthony on the crate. So, as we have learned, work equals force times distance. And we know the force is 100 newtons and the distance is 20 meters. So it's a 100 multiplied by 20. And that gives us 2000 joules or 2 kilojoules. Power is the rate that energy is expended over a given time interval. Therefore, the formula for power is power equals energy divided by time. And the units for this are work is in joules, time is in seconds, and power is in watts. In the example below, we can see two cars that are traveling over the same distance. However, one car makes that distance in a much shorter time. Now, if the energy required to move both cars over that same distance is the same, then we would say that car that is able to make the distance in a shorter time is more powerful. Even though it is expending the same amount of energy as the other car, it is doing it in a much shorter time. So in this case, even though we have more power, one car, the amount of energy that is expended for that distance is the same because the time is different. So let's work through an example to better understand the relationship between power, energy, time. Emma uses a 240 volt 1 kilowatt vacuum cleaner for 30 minutes. The question is, how much energy does she use in these 30 minutes? We know that power equals energy divided by time. Therefore, energy is equal to power multiplied by time. And we know what the power is. That's 1000 watts or 1 kilowatt. We need to convert the time, which is in minutes, to seconds. So that's 30 multiplied by 60. Multiply that by 1000 and get 1,800,000 joules or 1.8 megajoule. As a check, we can calculate the power using the energy that we've just worked out. We take 1.8 megajoules and divide that by the time, which is 1800 seconds, but that's 30 minutes. we do arrive back at 1000 watts, which is 1 kilowatts. So it works out. Efficiency is the proportion of useful energy output compared to the energy we input. Therefore, the formula for efficiency is energy output divided by energy input, which is the same as work output divided by work input. Now, if the energy output and energy input is measured over the same time frame, then it's equivalent to the power output divided by the power input. And the units for efficiency is usually expressed as a percentage. And we would normally want efficiency to be as high as possible because we want to get maximum amount of useful energy output. So let's work through an example to practice what we've just learned on efficiency. Here we are asked to calculate the efficiency of a steam engine if for every 600 joules of energy in fuel, 60 joules is converted to motion. Now, we've just learned that efficiency equals energy output divided by energy input. In this case, we know the output is 60 joules. That's the useful energy that we want, that is the motion. And there's 600 joules of energy that's input. So that's 60 divided by 600. That gives us 0.1 or 10% steam. In the previous module, we learned about mechanical advantage and velocity ratio with respect to pulley systems. Mechanical advantage is defined as load divided by effort, where load is the load force and effort is the force that we apply to actually lift that load. And velocity ratio is defined as the distance moved by the effort divided by the distance moved by the load. And we shall see how both these values relate to efficiency. As you know, efficiency equals work output divided by work input. Now, work is force multiplied by distance. And therefore, the work output in this case is the lifting of the load. Therefore, it is the load multiplied by the distance moved by the load. And the input is the effort that we apply to lift that load. And therefore, it's the effort multiplied by the distance moved by the effort. Now, we can separate out the load and effort and the distance moved by load and distance moved by effort. As you've seen from the previous page, load divided by effort is mechanical advantage, and distance moved by effort divided by distance moved by load is velocity ratio. Therefore, efficiency equals mechanical advantage divided by velocity ratio. Hence, in lossless ideal cases, efficiency is 100%. And therefore mechanical advantage equals velocity ratio. However, if mechanical advantage is not equal to velocity ratio, we will have efficiency that is not 100% and would usually be mechanical advantage that would be less than the velocity ratio because it's impossible to be over 100% efficient. So the key point here is that in lossless ideal cases, mechanical advantage equals velocity ratio and therefore efficiency is 100%. So now let's work through a few practice examples. A motor is used to lift a 1200 Newton concrete block with a cable. The motor lifts the concrete block 16 meters vertically as shown. We are asked to calculate the work done on the concrete block by the attached cable. So at this point, Please pause the video while you work through the problem yourself and resume the video to see the solutions. To calculate the work done, we need to understand what the force is, and we're actually already given the force. The force is 1200 newtons. Therefore, we simply need to multiply the force by the distance that the load is traveling, that is 16 meters. Therefore, it is 1200 multiplied by 16, which gives us 19,200 joules or 19.2 kilojoules. And the answer is D. Next practice example, we have a motor that produces 12,000 joules of energy in 4 minutes. And we are asked to calculate what the power of this motor would be. So please pause the video at this point and try and work through the problem and press resume to see the solutions. Okay, power equals energy divided by time. We know what that energy is, that's 12,000 joules. We need to convert the time from 4 minutes to seconds, which therefore is 4 multiplied by 60, that's 240 seconds. Therefore, 12,000 joules divided by 240 gives you 50 watts, and the answer is D. In practice example number 3, we have a bus running on biofuel made from coffee grounds. The bus produces 0.24 joules of energy in the form of motion for every joule of energy provided by the biofuel. And we are asked to calculate the efficiency of the biofuel. So please pause the video, then work through the problem and resume to see the solution. Right, efficiency equals energy output divided by energy in. And we know that we are getting 0.24 joules of energy in the form of motion, and that's the useful energy that we want for every joule of energy provided by the biofuel. So for 1 joule of biofuel, we get 0.24 joules. Therefore, it's 0.24 divided by 1. Gives us 0.24, which is 24%, and the answer is C. In the final example, we have a hydraulic leveling system used in a caravan. This system has 4 flip-down hydraulic jacks, one at each corner of the caravan. Each jack can raise the floor of the caravan by up to 12 centimeters. Has a maximum rated capacity of 3,000 newtons. If it takes 20 seconds to raise the caravan floor by 12 centimeters, calculate the maximum power required by each hydraulic jack. And we assume that each jack is 100%. So we are given 2 formulas there. Work done equals force times distance, and power equals work done divided by time. So please pause the video at this point and work through the problem, then press resume to see the solutions. Using the first formula that was provided, work done equals force times distance. We know that the force is 3,000 newtons, and we know that the hydraulic jack can go 12 centimeters, which we need to convert to meters. Therefore, it's 3,000 multiplied by 0.12 meters. That gives us 360 joules. Now, power equals work done divided by time. And we've got the work done, and that's 360 joules. And we know that it takes 20 seconds. Therefore, it's 360 divided by 20, which gives us 18 watts. That's the solution for example 4. This brings us to the end of this module. Several examples and practice questions in this module were taken from the BCE end of year examinations for systems engineering. I hope you enjoyed this module, and thanks for your time.